Okay, today we're going to be talking about ions. So an ion is a charged particle, okay, so it has a different number of electrons than it does protons. So up until now we've only been talking about neutral atoms. So an example of a neutral atom would be hydrogen. Oops, I don't think you can see that. Hydrogen is an example of a neutral atom. All right. Another example of a neutral atom would be, for instance, nitrogen. All of these are neutral atoms because the number of electrons is equal to the number of protons. When we're talking about an ion, we're saying that the number of electrons is not equal to the number of protons. Something that you want to keep in mind is that you're never changing the number of protons you have. You're only changing the number of electrons. Protons are stuck in the nucleus. If we were to change the number of protons, we'd be changing the entire element. For an ion, it's still going to be the same element, but now it's going to have a charge. Okay, so how are we going to figure out what charge all these different elements have? So, what we need to think about is our noble gases. We know our noble gases are this very last group over here. These are our noble gases. We talked about in class already how our noble gases don't react with anything. We already talked about how they have a filled outer shell. So like when we're doing our electron configuration, it's completely through the p level, okay? And it doesn't want electrons, it doesn't want to get rid of electrons. It is happy exactly where it is. So our noble gases are going to have a charge of 0. All the electrons it has, it wants. Okay, now if we're going to start going right to left, okay? So if we're going to go over one column, now we're in our halogens, okay? Our halogens, if we were to do the electron configuration for, say, fluorine, okay? So if I were to do the electron configuration for fluorine, it'd be 1s2, 2s2, 2p5. Okay? In order for it to have a filled outer shell, which is where it wants to be, it needs to gain an electron, going from 5 to 6. In order for it to gain an electron, we are going to have to put a negative charge on it. So I know that kind of seems a little weird. You're saying a -1 charge, but now you're adding an electron. We need to remember that electrons are negative. So the more negative charge you have on it, the more electrons you have. Same thing goes for positive. So if you have a positive charge, you have less electrons because the whole atom in general is less negative, being more positive. Okay? So the charge that this entire group is going to make is a -1 charge. If I were to ask you what is the ion form of chlorine, for instance, you would say if chlorine was in an ion, it would be Cl1-. You can write Cl1- like this, or like that. Oh, that's the same. Or like that, or just like that. All of these mean the same exact thing. It doesn't matter if you put the minus first or the minus second, makes no difference. Okay, any of these ions that are going to become negatively charged, we're going to call that an anion. An anion is a negatively charged particle. Okay? So now if we were to go over to the next group, all right, it would now need 2 electrons to have that filled outer shell. So this is all going to have a -2 charge. If we go to the next column, it's going to have a -3. Okay, we're going to stop at the -3. The reason why we're going to stop at the -3 is because if we go over to the next group, you would be thinking it'd be -4. So -4, if you add 4 electrons, it would have a filled outer shell. But the same thing would work the other way, because we know that a shell can hold 8 electrons, right? So if we were to go the other way, we can get rid of 4 electrons, and then we can just have the shell before it be filled. So what we're going to do is we're not going to worry about this row right here. Okay? Now let's start back over here. When we're in our alkali metals, we are 1 over having a filled shell, right? So if I were to do the electron configuration for lithium, it'd be 1s2, 2s1. I have 1 more electron than I need to create a filled outer shell. If I were to get rid of this 1 electron, now I have a filled outer shell and lithium can be happy, okay? So this entire column, so this entire first group is going to have a charge of +1. This next group is going to have a charge of +2. Now you can get rid of 2 electrons, okay? In here, so these are our transition metals. Transition metals can have multiple charges. We're going to talk later about that, not right now. So when we're figuring out charges through groups, I want you to kind of just forget about these for now, okay? These are all going to be positively charged, and we're going to find out more about that later. So we're going to skip over our transition metals and then go back to the group that we have left blank. So we're +1, +2, and this last one is going to be +3 because you can get rid of 3 electrons. What you need to do is you need to be thinking about going to the closest filled shell, whether that is adding electrons or if that is subtracting electrons. Okay? So we already talked about our negatively charged ions being called anions. Now all these positively charged ions, those are called cations, and it's the positively charged particles. If you notice, your positively charged particles are your metals, okay? Your metals are always going to form a cation if it is in its ion form. Your nonmetals are always going to form your anion. Okay, so think about some questions that I can ask you for this. So if you look at our periodic table here, what I can do is I can ask you, what would be the charge for an ion of boron? So you'd have to think about your charges and think about your filled shell and say, if boron was an ion, it would have a +3 charge, okay? If I had barium, what would the charge on that be? It would be a +2 charge. If I had sulfur, the charge on that would be -2. All right? So I hope you wrote down all of this stuff because it's all really important. And we're going to go over some more examples of this in class.